Good morning, students. In today's video, we are going to cover two main topics, that is lithospheric flexure and the concept of equilibrium. So let's get started. So the first is lithospheric flexure, in which you can see this word lithosphere. So lithosphere, as we all know, is made up of crust plus upper mantle, and it extends up to 100 kilometer. And when heavy weight comes on earth's lithosphere like mountains, it bends or sinks. So what happens is, the lithosphere contains the crust, okay, and when mountains are on this lithosphere, because of this, because of the weight of these mountains, the lithosphere little bit bends or sinks. Because the underlying layer is asthenosphere, which is made up of soft material and it's fluid like, okay. This bending of lithosphere is called the lithospheric flexure. Very easy phenomenon, okay. It usually happens over a wide zone of 100 to 300 kilometers. So it is very, means, nothing can be easy than this particular topic. I hope you understand. Flexure isostatic uplift, so it is part of this lithospheric flexure only. When erosion removes weight from mountains, the lithosphere rises back up. This is flexural isostatic uplift. So what happens is, erosion means like wind, like these are some you can say agents of weathering, that like wind or water. They take away the upper layer, okay, like the crust. They move the particles on the upper layer from one place to another, okay. So this is what happens in the erosion. So because of erosions, remove some weight from the mountains, okay. So because of like wind, some of the rocks present on the mountains moved away. The lithosphere rises back. This is flexure isostatic uplift. So because of that, the weight of the mountains reduces, and the lithosphere, it also comes back to, it also rises, okay, because of the decrease in the weight of mountains. So this is called the flexure isostatic uplift. So as the name suggests, uplift happen because of this, means removing erosion process. So about 80% of the eroded rock is replaced by this uplift, helping maintain mountain height for a long time. So what happens is that this 80% of the rock eroded rock is replaced by the uplift. So uplift happens, okay, means these rocks eroded away or moved away, and because of that, the full weight of the mountains decreases, and the underlying layer, that is the crust, rises back, okay. And because of this, the mountain heights remain the same. This process affects mountain evolution and also influences ice sheets. Their weight causes sinking and melting, cause uplift. So this mountains phenomenon also happens with these ice sheets, okay. So basically, this whole, let me summarize this whole topic for you, um, that this erosion removes some of the rocks and layers of the mountains. Because of that, the weight of the mountain reduces, and the underlying layer, that is crust, it moves back, okay. And then because of this, the height of the mountains remain the same, okay. and the concept of equilibrium. So equilibrium is like a balanced state. So the isostatic equilibrium means the crust and mantle are in the balanced state. Means the crust and the mantle, like the lithosphere and the asthenosphere, are in balance. The lithosphere contains the crust and upper mantle floats on the softer flowing asthenosphere. We know that. How deep a block of crust sinks depend on its weight and density. So if the block of crust is heavy, it sinks, okay, and if it's lighter, it will float. A heavier and taller block like mountain sinks deeper into the mantle. So it is pretty like common sense. A lighter block sinks less and stays at higher level. Each block of crust adjusts its height to match its relative mass. This balance is called isostasis. So whatever like a block of crust like mountains or whatever present on the crust, because of that the means because of that they adjust their heights. Suppose if you have a heavy mountain, the crust adjusts itself, it sinks little bit. And if you have like lighter surface and if you have no mountains, so at that point the crust will be flat. So according to their density or weight, they adjust themselves, and this adjustment and the balancing is called the isostasis. When forces change like erosion, deposition, volcanic activity, the crust moves up and down to restore equilibrium. So these forces change, and the like erosion, as we have seen in the previous slide, that what does erosion do in the process of this isostasis. So the crust moves up and down because of this, and the restore and at last they are not always constantly moving up and down. Like crust is not always moving up and down. After some time it restores the equilibrium. So today's homework is to make an image in your mind explaining this concept. Okay, so you just draw a picture in your mind with the help of your imagination. So what my aim is to improve your imagination. As Albert Einstein said that imagination is more important than knowledge. So that's with this that's it for this video. Thanks for watching.